This is honestly one of my favorite lessons. It's how to create a list of all two-digit primes. But specifically, we're going to do this using something new, which is called continue. And I'm going to go ahead and explain what it is in the example. Okay, so what we're going to do here is we're going to loop through the numbers, all the two-digit numbers. So let's just say for, I want to define that it's a number. So for number in range, so what do I start with? I start with 10, and I can go all the way up to 100 because I actually want to finish at 99. Now what I want to do is check to see if each of these numbers is prime. Okay, so how might I do that? Well, I've got to check the number. And so the first thing I want to do is I want to check if num mod 2, right? So recall that mod 2. I want to check is 10 divisible by 2, right? So 10 divided by 2, right? It is divisible by 2, so it's not prime. So if that's equivalent to 0, right, then it's not prime. And what do I do if it's not prime? Well, this is where I want to introduce continue, okay? So if I type in continue, this is sort of a keyword in Python. You can see it's been color-coded. What this means is you're not going to do anything. You're going to continue through the loop, meaning you're going to go on to number 11. And when you get to number 11 and you check, hey, is this condition met? It's not met, and so we want to keep going. And check what? We want to check if now is it divisible by 3, right? Is num mod 3 equivalent to 0? Okay, now this isn't going to be the case for 11, but for 15, right, it is. And so what do we want to do there? We're not adding anything to the list. We just want to continue, okay? You see the pattern here? So we can keep doing this. Now, when I press return, okay, and I'm inside of this if I press return, I stay inside of the if. But all I want to do is I want to continue. And continue means go back to the beginning of the list. Okay, but if you make it past 2 and 3, the next prime to check is it divisible by 5, right? And hey, if it is, like 25, then we don't want to put that number in our list of primes. We want to continue and go back to the top of the list. If it makes it through 2, 3, and 5, what if we get to, we've got to check 7, right? So is the number mod 7 now equivalent to 0? Okay, if it is, it doesn't make it through. We want to go back to the beginning. So what we're doing here is we're sort of making like a sieve, and for a number to make it through, it's got to be so far not divisible by 2, not divisible by 3, not divisible by 5, and not divisible by 7. Okay. What's next? Well, the next prime would actually be 11. And 11 squared is 121. Okay. So if 11 divided into the number, like say it does for 77, well, it would have to be times another number, right? Because it's less than, we're only checking two-digit numbers. We're not checking more than 121. But we've already checked all of the previous prime numbers, okay? And so you don't have to worry about the composite number because any number can be written uniquely as a product of its primes. And so because 11 squared is 121 and that's the next prime, we can stop here, okay? If 2, 3, 5, and 7, if each of those numbers, if none of those numbers divides the numbers between 10 and 100, it's prime. What we can now do is add it to our list. Now we haven't set up a list, so we need to do that. And so we'll call this maybe two-digit primes, okay? It starts off empty, of course. And the only way it's getting through this is by getting, making it through all these if checks. Because like, again, if you check like 49, right? Once it gets down here, it's gonna say, oh, that's true. So we continue and we go back and we check 50. 50 will stop here. And 51 will stop here. And 52 will stop here. See, it's hard to get through. But 53, not divisible by any of these. And so what we need to do in that case, you got to line it up in the right place. Okay, it goes with the ifs, right? Because it's got to make it through the ifs. We simply want to append the number. So this is a super, I think, clean and cool way to sort of like show all two-digit primes. Okay, so let's give it a whirl. And of course, we want to check it, right? We want to print it out at the end. Did it work? And one last time, what that continue means, right? I mean, it's going to start with 10, right? So 10 comes here. Is 10 divisible by 2? Yes. So this condition is met. We're inside here. Continue means you go back and now you're on 11. Okay? So let's run it. Press Shift Enter. Hopefully it works. Kind of exciting. You got to make sure everything's lined up correctly. If it's not, things can go a little haywire. And look at that. It appears to have worked. This looks like all the two-digit primes. And I say that because as I scan through and I check some random ones like 61, well, 7 doesn't go into 61. I know 5 doesn't because it doesn't end in a 0 or 5. For 3, you can do the trick and say, well, 6 plus 1 is 7. Does 3 divide evenly into the sum 7? No, so it's not going to divide evenly into the number. Okay? And 2 we know because if it's even, it's divisible by 2. So this is a great way to get all of the prime numbers. There, scrolling to the right, looks like 97 is the only one over 90. It's sort of interesting. 91 is 7 because, 7 times 10 is 70, right? And then there's 21 to get to 91, and that's also a multiple of 7. 93, 9 plus 3 is 12, okay? So that's divisible by 3. 95 ends in a 5, and 99 is divisible by 3. Yeah, so this is great.